So in our class, we've been working on some stuff with coordinate geometry. We've been working on midpoints, distances, and slopes. And I just wanted to show you a little bit of work with the midpoint and calculating slopes and distance based on the midpoint. So what you can see here is I've got a random point AB, a random point CD. So that's the red point here and the purple point. And as I slide the red and the purple point around, I've programmed it so that the blue point is exactly in the midpoint. And the way I did that is just by using our midpoint formula. You add the two x values and divide by 2, so a plus c, and you add the two y values and divide by 2. So you can see for yourself that no matter where I put the red point and the purple point, the blue point is going to sit halfway in between. And so what I wanted to show you was that when you have your line that connects them, you can find the slope between points A and point B, and we'll call this point M in the middle. We can find the slope that goes all the way from point A to point B, or we can find the slope that goes from point A to point M. And what I want to show you is what happens to that relationship in general. So the slope, which we use a lowercase m for, is just our rise over run, our second y value minus our first y value, our second x value minus our first x value. If you want to use the letters that I used over here on the left side, the way I would write that is just d minus b over c minus a. But you can use the y2s and y1s if you want to. Now that's the slope between a and b, so I'm going to call it m between a and b. I could also find the slope between a and m, and that would look like this. I take the y value of m, b plus d over 2, and I subtract the y value of a. I can take the x value of m, and I subtract the x value of a. Now somehow, it looks like this should come out to be the same slope because they're on the same line. And intuitively, it makes sense that we get the same slope when we have 2 points on the same line. So what I can do here is find a common denominator because I have fractions on the top and fractions on the bottom. So I'm just going to look at the numerator. I see something over 2 minus a whole number b. I can take this b and multiply it by 2 over 2. That's okay to do because 2 over 2 is equal to 1. So all I've really done is taken the number b and multiplied it by 1. I'm going to do the same thing with the number a on the bottom. When you do that, you create common denominators. So now I have b plus d minus 2b over 2. And on the bottom, I have a plus c minus 2a over 2. Now, I see a fraction divided by another fraction. So two ways I can proceed. I can think of it as multiplying by the reciprocal of the bottom, or I could just multiply top and bottom of the big fraction by 2. Let's do the multiply by the reciprocal. And while we're at it, let's simplify. We've got like terms. B minus 2b is just negative b. A minus 2a is just negative a. So now I've got d minus b over 2. And I'm going to multiply by the reciprocal of the bottom, c minus a. Well, times 2 and divided by 2 cancels out, and we get exactly what we wanted, d minus b over c minus a. So what we just showed is that the slope from one point to the midpoint is the same as the slope along the entire line segment, and that's great. One other thing that I wanted to show you here is that the distance to the midpoint is exactly half of the distance of the entire line segment. And that makes sense. Like we think of the word midpoint as being halfway. So the distance between A and B is just like Pythagorean theorem. So we just do the second y value minus the first y value squared plus the second x value minus the first x value squared. Well, we can do the same thing with the distance between A and the midpoint. It's the square root of the second y value, b plus d over 2, minus the first y value squared, plus, let's do the same thing, the second x value minus the first x value squared. I'm going to do basically the same thing that I did with the slope proof. I'm going to multiply by 2 over 2 to make a common denominator. So now I know I have the square root of b plus d minus 2b over 2 squared. And here I have a plus c minus 2a over 2 squared. Combine my like terms, and I have d minus b over 2 squared plus c minus a over 2 squared. It looks so close to the original distance that we got here. Just compare and contrast for a second. The only difference is we have an over 2 in both of those. It turns out that when you have a fraction and an exponent, you can distribute the exponent to top and bottom of the fraction. So we have d minus b squared over the 2 squared, which is 4. Here we have c minus a squared over 4. Well, now it turns out that I have two fractions underneath the square root, and those fractions have the same denominator. So just like we did a couple times in this video already, we have a common denominator of 4. You might be worried now, oh wait, we're supposed to show that it's half the distance. Well, just like I distributed here, I did square the top and square the bottom, square the top and square the bottom to get to this step here. I can distribute the square root. Square root of the top, d minus b squared, plus c minus a squared, over the square root of the bottom. And what's the square root of 4? It's 2. Dividing by 2 is the same thing as half. So I have half the original distance. And so in this video, I just wanted to show you a little bit of work with midpoint and distance, and showing you that you can actually prove that the slope between the endpoints is the same as the slope between the midpoint and one of the endpoints, and that the distance between the endpoints is twice as big as the distance between an endpoint and the midpoint. So please let me know if you got any questions, and I'm happy to help out.